Yes, it is. Tim. So here's what. I like teaching math, but at this level, the reality is we always want to model it to make it feel like it's real stuff, because you're like, when are we ever going to use this? And a lot of the math we do, we don't, which is why there are two types of math that I really like. One is I got really into those word problems during trig because trig really works. You can really figure out distances. Like in real life, that's how surveyors do measure things are far away. That's how astronomers do it. They use trig. So I like trig. I also like logs and exponents because we really use them. Because in real life, things don't go at a normal linear pace. You don't have a problem like this in real life. Your Nana gives you $20 at every birthday. If you are 10, how much money has Nana given you? Like Nana doesn't do that, right? And in real life, we do things that are more interesting. Like we take Nana's money, because if she gave us a nice chunk of change, and we invest it, right? And we want to see maybe we can make some money off old Nana. Or sometimes we have zombies attack, right? And zombies don't grow one zombie a day. Zombies are eating constantly, and they make new zombies, and the new zombies eat constantly. So things get big very quickly, or things get very, very small quickly. In real life, so this is a quick story. My children, every year, I had to read a biography when they were like in 5th grade, and all 3 of my kids read the same book. And it was about this nature-y woman who was kind of like a granola mom, and she let her kids do this weird little science experiment for their grade school, and the daughter got 2 mice and put them in a cage. This is a true story. And the mom and the granola mom, she just let it go for 2 months to see what would happen. And finally, at the end of 2 months, the cage had like 60 mice, and they were eating each other. And my own children just loved that. They're like, oh my God, why won't you let us do that? And I thought, you're just horrible people. So mice don't grow 1 mouse, 2 mouse, 3 mouse, because the mice mom has nice babies, and then her babies have babies, and then the babies have babies, and then they start eating each other, and then it's fabulous. Same with money, right? If you are putting money in a bank, there's a reason that there are some schools of thought that say we should not have billionaires, because there's a thing called wealth absorption. So here's what happens. There are some people that have so much money that just literally putting it in a bank, it absorbs so much interest that it kind of starts killing the economy. Does that make sense? Because if you put $5 million in the bank, literally you start just sucking up so much with just interest. And they say that that's why you get such big income disparities, because of these really hyper rich people. They don't even have to do any work. They just have to invest that money, and they just start sucking up the resources. Viruses. This is the one moment during COVID where I have my moment to shine as a math teacher. I literally was in the grocery store, and some lady said to the cashier, I don't believe COVID is real, because there's no way you can have 10 cases one day and then 100 the next. And I'm like, and my kids are like, don't say it, Mom. Don't say it, Mom. I'm like, exponential growth. Like I just was, but I didn't. I didn't say this. And my kids, I know, but it was true. I felt that way. And my own children were like, please God, please shut up. Because they knew I was all excited about it. So we are going to talk about exponential growth and decay. And I like it. So I have notes for you. And here it goes.
There's a reason why I got paper.
You know what? Because word problems are harder right now. No pages for you.
Is this are we going to watch that scene from the zombie movie where they climb up the wall?
Oh, I didn't do that. Okay.
Oh, got a garage?
Okay, here we go. So, a lot of people said this. in my other classes, they said, didn't we do this in Algebra 1? And the problem is, you did the beginnings of it in Algebra 1, but you never solved for time. And I'm going to show you why. So here we go. We're talking about exponential growth. And the first thing that we need to know is that there is a general formula. And then we're going to talk about very specific ones for very specific times of day. Jackson, put it away. Or very specific problems. I won't make you memorize these. The problem will say, here's the situation. Use this formula, because really I don't need you to memorize the formula. I need you to know how it works. But the general formula for anything that's getting bigger really fast or smaller really fast looks like this. Y equals AB to the X. And I'm going to tell you a couple things. I'll put a little dot there. I put it right underneath that exponential growth because I'm going to give the formula that we're using today in a minute over here. But we're going to use a couple formulas over the next 3 days. We're going to talk about man-made stuff, money and depreciation. We're going to talk about things that grow in nature, zombies, viruses, bones, half-life with calcium. And then we're going to talk about things that are radioactive. So we'll do all of those. They are slightly different formulas, but they all set up like this. They will all have right here an exponent, right? So sorry, my B went away. They're all going to have an exponent. We call this B right here the multiplier. We call them the multiplier. If things are getting bigger, that multiplier is bigger than 1, and that is called growth. If that multiplier is between 0 and 1, like a decimal, a fraction, it is decaying. It's falling apart, right? You're going to need to know those words. Things that are growing, getting bigger, they are growing or they are decaying. And there are some people that say in life, we are always doing one of those two things as human beings. We are either growing or we're decaying. We never just stay static. Okay. We are, you guys are growing. I said they're decaying. Because I'm heading down, right? I'm on the downhill side. So here we go. Let's talk about human stuff. The formula we're going to use. It's a variation on this guy, but we're going to use some slightly different numbers or letters that will help you. You guys ready? Write this down. A equals, and maybe you've seen this, P to the 1 plus RT up there. I know, it looks crazy, but I'm going to tell you what those letters mean, and you're going to be like, nice and easy. The first thing I want you to notice, though, is this. See how this, oh, God, why? Come back. Maybe, oh, no, maybe it won't come back. This guy right here, my board is so finicky today. This guy was my multiplier. Liam, this guy is my multiplier over here, right? And if it's growing, it's going to be bigger than 1 because it's going to be 1 plus more stuff. That is called your multiplier. You're going to need to know that. So here we go. What the hell is A? You know what A is? A is the ending amount. So let me give you an example. Your Nana gives you a bunch of money. You put it in the bank and you let it sit there for 10 years. How much you have at the end, that's your ending amount, right? Yay, you made some money off old Nans. Yay for you. P, we call that principal amount. That's your starting place. That's how much you're putting into the bank, right? Starting amount. For example, if we find out that the teachers who are chaperoning senior ball, unbeknownst to you, had gone out the night before and all got bit by a zombie, and then they got to senior ball and they are all zombies, that means you start senior ball with 4 zombies. We might want to find out how many zombies leave senior ball. It might be a lot, right? So the starting amount of zombies, that's our P. The next thing is R. That is always going to be our rate of growth. But I need you to be careful. They are going to give it to you as a percent, but we use a decimal. some of you suck at changing things from percent to decimal. So we're going to need you to be careful on that. And obviously, T is time, which is why T on these often should be a positive number. You can't go back in time. So we're going to start with a nice, easy one. You need a calculator out, not a phone. Your phone does this all backwards. So don't practice on your phone. I got calculators. Use mine if you don't have a scientific big babies. But you have to make sure we have a calculator out to do this first problem. So here you go. So sweet Nana gets $1,800. She's decided to start giving away her money. And she tells you got to put it though in an interesting, and you got to hold on to it for 15 years. So we want to see how much we're going to have at the end, right? So we are going to get our little formula out. A, P, R, T. Now I'll be honest, you don't have to do this part, but it helps me. It also helps me help you on a test. So if you get the wrong answer, I can go over here and check and be like, oh, you got your P and your R, your P and your A. So we're starting out with $1,800 right there. Our rate is not 7. There you go. Not even 0.7, 0.07. So many of you get that wrong. We're going to invest it for 15 years. So here we go. A equals 1,800. Here's my multiplier. 1 plus 0.07 or 1.07. And we're raising that to the 15th power. Get your calculator out. I need you to do this in the right order. The order of operations with exponents says every time. What is wrong with my board today? We are going to start right here. And I'm going to show you your calculator has a little button that looks like a carrot. Find the button that looks like this. You know what that means? It means to that. So we're going to punch in 1.07 to the 15th. Hit enter. Times it by $1,800. How much of that sweet Nana cheddar do you have now? How much? 4. That might not go no. So let's talk about, again, that seems like not that much. But if you're a billionaire and you've done nothing to add to the economy, you have just put in $2 billion into the bank, and now you're taking out more than double that amount, and you haven't added, you just sucked up resources and put nothing in. So that's why some people believe we shouldn't have either. Sorry. No, here comes the next problem. Oh my God. I need to have more friends. I thought when I wrote the problem, this would be so clever because I have so many Owens. I have this Owen. I have that Owen. I have this Owen. Look, there he is in his little black shirt. But that Owen wore a pink shirt. So guess what? He has to be Nana. So there he goes. So there you go. Sorry, Owen. So if he's here, someone wants to take a picture of Owen being Nana. You can do that. There he is. Sorry for the That's right. He's Meemaw. There he is. He's Meemaw. So yes, did I spend 45 minutes doing that? Sure I did. Okay, here we go. Owen's Meemaw loves him very much. She gives him $2,000, and she says, you can spend that money once it reaches $3,600. And my question is, how long does Owen need to keep it in the bank? This is why this becomes algebra 2 trig and pre-calc, because we are looking for T, and we've never done that before. So here we go. Our principal, I'm going to write my little P. Our P is 2,000. Our ending point is, Tim, 3,600. Our rate is 0.06, and I'm looking for T. So let's write this equation. Are you ready? So we're going to say 3,600 is my ending point equals 2,000 times my multiplier, which is 1.06. That's a pretty good interest rate, by the way, to the t. Now, here's the problem. T is trapped up there. It's a battle in your air. You need to bring it down, and there's only one way we know to do that, using logs. So before we can do that, though, we have to isolate this guy. So please move that 2,000 over right now with your teammates. Move that 2,000 over. Divide both sides by 2,000 because we want it to be alone. Hopefully you should get like 1.8. Is that right? Equals 1.06 to the t. Now I'm going to bring that t down by using logs. LOG, LN, I don't care, but use the same one whichever you use. So here's what, Jace, you picked this class, so you can't make it harder for me. Okay, so just, okay, just don't make my life harder. Okay, so now I gotta bring that T down. Boom, he's down here now, right? Nice and easy to get rid of that, give that T by itself. We're solving for T, 1.06. 1.06 log ln. Now, before I do this, I'm going to think to myself, clearly it's going to be more than a year, but I think it's going to be less than 20 years. So I need a number that's somewhere in there. If I get like 0.31287, that doesn't make any sense. And if I get 5,000, that doesn't make any sense. So let's make sure we're going to get an answer that's at least somewhat sensible. So I'm going to go ahead and I'm going to hit ln, nice and easy. 1.8, close my parentheses, divided by ln 1.06. It looks like old Owen, is, if he's 18 now, you can't pull that money out till you're 28. Well, when you're 28, you know, 3,600 bucks, why not? You know what? So there you go. So 10.08 or 10 years. How did I know it was a year? Because it's per year. That's it. That's it. Let's do something that gets smaller. You ready to do something that gets a little smaller instead? So let's say our friend Jace decides to start a business. We're going to do that in a second. And so this time, decay, there's only one change. We need it to be a decimal in that multiplier. And here's what it looks like. Write this down. A equals P. Everything's the same. 1, and we're going to have R, and we're going to have T, but I need this to become smaller than 1. So you know what I do? I subtract the rate. What's my A? It's my ending. What's my P? That's my starting. What's my rate? R is rate as a decimal. And my time. So here we go, Jace. We're doing it. We're investing in Jayco. That's Jaceco. No, it's Jayco. Get it? Jayco. Yeah. Okay, then it would just be Jacko. Then it would look weird. So we're investing in old Jacko. And you know what? We feel confident he will eventually make money. But after 9 years, not so much. So we made an initial investment. We started at 12 grand, right? We gave him 12 grand. We believed in him. And every year we're like, how's it going? He's like, one more year, I'm going to turn the corner. And it turns out, though, our time has been 9 years, hasn't turned the corner. And he has been losing money, 4% a year. Now, we're going to be careful with this 0.04 because we're not going to make it 1.04. We're going to subtract it, right? So our formula is going to look like this. 12,000 bucks that we invested multiplied by 1 minus 0.04. That, by the way, is 0.96. And we're going to let that ride for 9 years. Can you tell me how much of our money's left? It could turn the corner the next year, that's it. I have full confidence. Huh?
To the moon.
God,
That's
To the moon. I invest now.
It's coming, it's coming. It's
The
coming.
pennies start now, but it'll be
That's
like
right,
video.
it'll be worth something. That's right. So remember, we're going to start with the 0.96 to the, right? Get your little caret, 9, and then multiply that. Oh, we've taken a hit, haven't we? All we have left in our investment, 8,300. No. So we've lost about 3,700 bucks. It's gonna turn around and then,
We lost no money.
so I did this first. And then raise it to the 9th power. And then times it by 12. Okay. Lucas is fixing you. Last problem. Here she is. So you thought we were free. You still are. Wow.
You can't round it up. You have to use the whole thing.
Yeah.
See that?
Why'd you come back?
I know, he's gonna keep coming back. Okay, so I could never imagine spending money on a purse, but my daughter does like it. So let's start here. This bad boy, I looked it up. It's a cute bag. It's 12 grand. With 12,000.
Antithesis of fun and joy.
It's ugly. So here we go. My girl Arya got a $12,000 bag for her graduation. Lucky her. But she knows that you can resell bags, and they depreciate. They're not worth as much when you have them, especially if you're not just keeping them up. So she wants to sell it when it gets to 8,000 bucks. So let's figure out how to do this. APRT. Be careful on this one. We are starting with a $12,000 bag, but we are ending at 8,000. Please, it's not always the big number at the end. If things are depreciating, Elena, you're going to have that big number sometimes in the beginning and not at the end, right? I just said it. Sorry, I forgot to write it in the problem. The rate of depreciation, it's going down every year by 0.06, and I don't know how long she's going to be able to keep it. Let's find out. So here we go. We're going to say 12,000 equals 8,000. No, sorry, that's wrong. You guys didn't stop me. 8,000, let's try that again. 12,000 times 0.94, and we're going to figure out T. So here's what I want you to do. I'm going to give you your steps. Get rid of the 12,000 first, and then take the log of both sides to bring that T down. Do it with your neighbors. Caesar, you're going to walk me through it as soon as you've got the answer. Yeah, just do it. No, you're not yet. Like everyone's doing it right now. You can just shout out the S. That's okay. I'll give you a minute. I'm not rushing you. Someone back there needs a calculator. You literally can't stop even when it's silent. I did 6-7.
I did 6 personally.
Wait, what?
That would be like totally not the right answer.
Who's to decide what the right answer is?
The problem, it's a suggestion. So the numbers are just suggested numbers. Where did I leave it?
Why? No, it's Louise handbook.
Oh, yeah, they look kind of big. They look kind of mannish.
Wait, can you scroll up?
Don't knock Arya's hands.
Wait, can you take her picture off of the? Why is that lady's arms bent so weird?
Because she's doing the model.
I know, but like her hand looks.
Well, I didn't make it happen. So, how long can she keep her bag for? About 3.5 years? About 2.5 years? Right, Caesar? 2.5 years? Okay, I'm stopping. Before you leave class, my lambs, I need you to at least get through the front page and 2 or 3 on the back. But the front page before you leave here, you got time. If you don't, gentlemen, Tim, if you guys don't do the first page before you leave, Sunday night, you're not going to have it. So please, before you leave this room, front page, then 2 more or 3 more, and you're going to get it.